Hello. Today I am giving a presentation on compressor fitted gasoline direct charge injection. My name is Anurag Burute and I am a student of Wollongong University, Australia. Now, why research on fuel administration system? Fuel administration system plays a very important role in internal combustion engines. As we know, today the world is crowded with internal combustion engines, those which we use in our cars, in our buses, trucks, even aircrafts and submarines. Everywhere we have to use internal combustion engines. Now, even though internal combustion engines cannot be avoided completely, we cannot stop using them completely. The fuel prices, because of that, the fuel prices are going higher and higher as the hydrocarbon resources we have on earth are limited. So the prices are going high and the emission laws are getting stricter and stricter and more stringent every day. Because of that, because of these changing laws and ever growing high fuel prices, the automotive industries have set certain aim as how to proceed in near future for automotive industry. Those aims particularly focus on maximum fuel economy to be extracted out of fuel, out of an engine, maximum power development with minimal amount of fuel usage, and while doing so emitting less and less emissions. Research so far. So whatever research that has been done so far, so as to reduce emissions, so as to increase the fuel economy, and so as to gain maximum power output. The basic component of a fuel administration system for a century, it has been the carburetor. Carburetor was developed in late 19th century and it has been same as such for whole century. It hasn't changed a lot and it works on a mechanical effect, that is a Venturi effect, which is the limitation of carburetor. Because of the carburetor working on the basis of a Venturi effect, when air passes through a small or a convergent passage, the velocity of the air increases, and doing so the pressure drops and the fuel is administered into the carburetor pipeline, which is showing the limitation of the carburetor. Okay, now fuel injection system. Basically, carburetor with carburetor we cannot change much because it works totally on a mechanical phenomenon. So as to change it, the administration of fuel according to ourselves, we have developed a fuel injection system which force the fuel at our convenience as we want into the combustion chamber of the IC engine. Now, these fuel injection systems had been in place for long years, but those were predominantly used for diesel engines before. For petrol engines, there wasn't such a development until the decade of 80s. From decade of 80s till today, there is a good enhancement in the field of fuel, that is gasoline direct injection. Please. So what are the different types of petrol injections that we see today or that has come so far? There are basically two types of petrol injections. Some which are injected into the manifold, that is the pipe connecting the carburetor or fuel injection system to the combustion chamber. If we inject the fuel in that port, it is called as port injection. And if it is directly injected into the combustion chamber, that is where it actually burns, it is called direct injection. These are the examples of the direct injection systems, basically these two, and the gasoline direct injection is the newest of them all, and mostly we see today of our cars or vehicles or bikes or anything, mostly they are fitted with GDCI, that is gasoline direct charge injection. This is the diagram example actually explaining the port injection and the direct injection. So as you can see, it is directly injected into the combustion chamber of the engine. So it is called as direct injection, gasoline direct injection. So the proposed design, that it is fitted with a compressor and using the basic principles of GDCI. Now, how will it work? Like simple mechanical change is there in this system, the proposed system, that a compressor is fitted and which is driven by the power developed by the engine. This compressor compresses the air and it pushes the air above into the fuel tank, above the fuel. Okay, so this pressurizes the fuel in the fuel tank itself. As you can see in the figure, the compressor is fitted above the fuel tank. It compresses the air and puts it above the fuel tank, and the fuel tank is directly connected to the injector. Now, in usual cases, as the so-called GDCI, the normal GDCI, which we take into consideration, somewhere here, a fuel pump would be fitted, so that whenever a signal is sent, the fuel to flow from fuel tank to injector, there will be a pump here which will pump the fuel at some pressure, and then it will send it to injector. That is next page. That is when a GDCI works, it will lag. It will have some lag to send the fuel from fuel tank to the injector. While as when we see this proposed design, in this there is no such lag, and most important thing here is just the air is compressed, that is air is handled by a mechanical system. The fuel is never handled by any mechanical system. The advantage again, another advantage of this system is we can learn ultra lean mixtures or the air fuel ratios in this internal combustion engine with the help of this system. The ratios which we can see are so-called. The lean would be the lean air fuel ratio would be 15:1. That is 15 parts of air is taken to burn 1 part of fuel. So-called so the ratios are there. Lesser the amount of fuel as compared to the air, richer the air fuel mixture goes. And richer fuel will ultimately conclude into lesser economy. So burning a lean mixture gives the advantage of gaining more and more economy, of course. And again, burning the lean mixture causes complete and clean burn of the fuel which we are providing the engine with. So there is no incomplete combustion, which is the main cause of carbon monoxide. That is incomplete combustion of carbon and unburned hydrocarbons, which is our fuel is made up of hydrocarbons, and if they go unburned, they are in the exhaust. So they are the main cause of pollution. And of course, the cost is decreased as fuel pump is much costlier than an air compressor. There are of course some disadvantages to the system proposed. Of course, the first one being the air compressor is much much higher in weight, which makes the system bulky. The power output drawn by the compressor through the engine may drop down the power of the engine itself. It can be fixed with a turbofan which is fitted at the exhaust port of the exhaust manifold, but it again may raise the cost of the system. And lean burning, this is the main actually issue with the system, that if we burn a very lean mixture, the NOx production, that is the main component of air which we are supplying engine with, burns the nitrogen itself and causes formation of nitrogen oxides. And of course, last but not least, noise. Air compressors are quite noisy as compared to fuel pumps, so the system may become a bit noisy. These are the few references I have taken the text from and gained my knowledge from. You are very welcome to go through them. Some more references, and that is the end of my presentation. Thank you very much.